Hello everyone. My name is Meraryslan. I'm gonna present you the results of the Young Scholars Project titled Artificial Intelligence Solutions for Advanced Urban Logistics. So this is the final year of the grant. It will end this December. Since it was some small miscommunication with what have to be presented here, so maybe I'll just add some extra details. So this is just roadmap. We can skip it to the next slide. So why urban last mile logistics? So in general, last mile delivery often counts for about 50% of total logistic costs. In some cases, it could grow up to 80% of the logistic costs. How do you understand the last mile delivery? So what last mile delivery?
The last stop that gets it to the final destination or final customer.
So usually in most logistic companies, we have the factory that produces the goods, some huge stores from which they distribute to other cities and so on. And from that small stores to the customer, this is the last mile delivery. So the last stage. And the most costs come from that part. How do you think why?
You have to deal with so many transportation.
Yeah, because usually when you get the goods from the factory to the storage, you just have few trucks that in 1-2 runs could deliver all the goods. But when you have the last mile delivery, it could have like thousands of deliveries per day. That's why this is extremely important topic. And nowadays, most companies use truck-only deliveries, but they have a lot of constraints such as traffic, infrastructure. Because of that, it could have increasing delays and, of course, carbon emissions. That's why in this research, we are considering the drone truck fleets, where we have the trucks that deliver the goods, and for some parcels, the drone could also deliver it, which is more efficient, faster, and has low carbon footprint. And yeah, these fleets could reduce congestion and cost while improving time to customers. And the key challenge here is the joint routing of heterogeneous vehicle, because it's an NP problem for TSPD. In our case, we have BRPD. The main difference between TSPD and BRPD that in TSPD we have single vehicle and single drone. In BRPD we could have multiple vehicles and multiple drones. And the key challenge here is to manage them, to make them interact with each other so that they will not be assigned to the same customer at the same time. Thanks. So, yeah, this is just some information about the grant. The funder is the Committee of Science, Ministry of Science and Higher Education of the Republic of Palestine. The type is fundamental research, not applied. The main priority is AI and intelligent decision-making systems. The university is SDU. We have, as a partner, we have the international advisor, who was Dr. Aygerim's supervisor from her PhD. And also we got some support from Nazarbayev University. They were giving us access to their computational resources, to their DGX servers. The total budget was 72,748,082. Yeah, this budget was split into 3 years. So the core objectives of the project was to develop the deep reinforcement learning framework to jointly route multiple drones and trucks for last mile delivery, and learn generalizable heuristics that complete with or outperform handcrafted heuristics, optimization heuristics. And main idea here is that we have like multiple vehicles, and for each vehicle, we have assigned drone to that specific vehicle, which means that the drone could work only with that specific vehicle. It cannot change battery or take the parcels from other vehicles. So this is one of the constraints that we have added. Can we go to the next slide? Yeah, and the main idea of like scientific novelty here is that classical research were focusing only on single vehicle routing to heterogeneous fleets. So it means that they have single vehicle and single drone, which is also a complex problem, but uh, much easier than trying to navigate them together. A road operation that has to be done, but for now it's under development, under construction. So we have completed the main part of the research, and this is just the additional novelty that we plan to develop further as a future work. Learning-based policies, adapt to instance change with resolving from scratch, which means that after each delivery, we reproduce the new environment, which means that once the parcel will be delivered, that customer will be disabled from the road. Or if some vehicle or drone will be assigned to that customer, we'll just cancel it from the road so that others will not consider that. Even if it's not yet delivered, if someone already going there. And here, the main challenge here is that sometimes, since the main constraint for the drones is the battery life, sometimes drone could fly to the customer, but there will be not enough battery to return back to the vehicle. That's why we need to consider this, and for that cases, we have to open that drone position only for the vehicle which is assigned to that. And to consider all these constraints, it was kind of a challenge for our research. And yeah, for capacity building, with the help of this funding, the AI lab at SDU was founded in the beginning. So because before we had only one computer, and with the help of this grant, we purchased like 5 GPU-based computers. And after that, Freedom came and also helped us to develop it further. Now we have like 12 GPU-based computers, really powerful computer that could be used even to train some small LLMs. Okay, further. So the main methodology is MDP formulation that we had to develop because since we are working with reinforcement learning and reinforcement learning mostly based on this MDP formulation where we have state, actions, rewards, transition probabilities. The second part is urban simulator where we have to develop the correct environment with heterogeneous speeds because as we know, since drones are not have these constraints of the traffic, they can pass the same distance we consider that they can pass the same distance 2 times faster. Of course, it could be changed in the real environment, but since it's fundamental research, we're just assume that they are 10 times faster. Next one is the deep reinforcement learning framework, which means like false ingredient reinforce was used for critic baseline and pointer style encoder. We have developed like I cannot say that we fully developed the new model. We just updated the existing model, which was developed from the PhD of the PI, Agirimo. We have developed it further. We have changed some attention mechanism there. And this really improved the efficiency of the model. Yeah. And at the last, which is now under the process, the enrolled operations. Enrolled operations is the operations for the cases where drone have not enough battery to travel to the vehicle or to the depot to recharge or change the battery. And for that cases, the enrolled operation that there are some points in the middle of the roads where the drone can fly and change the battery, like recharging stations. And in order to add them, like this should give us improvement to like for vehicle to not for people not to do some extra travels to the customer destinations who already had been served. So this is our MVP. For state, we assign the position of drone tracks, battery levels, remaining demand, and the current time step. Actions usually is next node for each drone and track. Reward is the negative total completion time or makes fun. And the goal here is to minimize this total completion time. And transitions, usually deterministic updates via simulator. Yeah, this is the classical formula for policy gradient that we also use. We can go. So this is the main idea for our simulator environment. We have so in general, when we solve vehicle routing problem, we solve it as the graph problem, where we have the nodes edges with end customers, and the edges. For each edge we define discrete and route retrieval or charging points that I mentioned before. Also reinforces battery capacity, speed, and truck drone synchronization constraints, as I mentioned before again. And recon training, we just started simple. Like when we just started this project, we developed the simplest environment where we just tried to make drones to take the actions with the to have some kind of beginning steps for vehicle and drone to work together. More we developed the project, we started to add like more constraints so that like at the beginning when the customer were assigned to the drone or vehicle, it's that customer still were available to others to see that this customer is available. There we had some problems and we decided to disable them once the vehicle or drone will be assigned. Next stage was to add the battery constraints to the drones. Also, we forced the vehicle to pick up the drone once the battery is dead. If the battery is dead and drone is stuck in the customer location, we force the vehicle to pick up that drone because this problem, based on the problem formulation, classical problem formulation for VRPD or VRP, the problem will be counted solved once all the customers will be served and all the fleets will be returned to the depot. Only in that case, it will be counted as solved. That's why when the drone is stuck on some customer location and our vehicles just return to the depot, we in general we can count this at the human that everyone was delivered and everything is great. But from the problem formulation, it states that each next stage it will penalize the model for not returning the drone. Yeah. For the problems that we had, another problem was that in general the model is reinforcement model is extremely lazy and usually decides that if I stay at the depot till the end, I will not get much penalty for not delivering some customers, but I will get less travel time, which means each time it stays at the depot, the total travel time will be equal to 0. With penalty, still it will be less than traveling to the customer. So this was the problem, and for that we just forced all the vehicles and drones at the beginning to leave with it. And once it returns, we'll just stock them at the depot so that it will not use depot as just to stay there. It will return only at the end when everybody is already like served. Main milestones of the year by year for this project. For 2023, we had the reviews, MDP formulation, simulator development and validation. So before applying to this project, we already started to work on review paper. We reviewed around like 100 papers on this topic. Then we started to develop MTP formulation and environment. For the second year, we already had some working environment. For that working environment, we started to develop the reinforcement learning framework. We had training test agents, and we started to prototype models and algorithms. During this work, we had developed around 10 different models with different constraints. And for final year, we completed the computational experiments versus benchmarks. And like one publication was done at the end of the first year, if I'm not mistaken. And the second publication was done at the end of the second year, or at the beginning of third year. Yep. So then the final is the final reporting and dissemination. So research team, our PI is Dr. Aygerin Gogurbayeva. We have senior researcher Dr. Azamat Jamanov and research assistants there. Ashat Serikbekova is from Transportation Academy. He is also PhD. He was PhD candidate. Meraliyev, it's me, Bisimbai Davletbayev, Yevnar Ahmedbek. So as the goal was also, one of the goals of this project was to train 2 PhD. It's me and Bisimbai Davletbayev and 1 master degree student, Yevnar Ahmedbek. Right now, as a result, 1 PhD already obtained degree and 1 master degree student also already obtained degree and started his PhD. For infrastructure, we have GPU workstations. At the beginning, we had the RTX 2080, which was not enough for us. Then we started to purchase RTX 3090, and with the given budget, we decided to purchase even better options. So the last workstations that we were purchasing were with RTX 4090, which is much better. Then we had the GitHub and Grammarly subscriptions and the foundation of AI Lab this week. So this is the budget summary. For the most of the budget were assigned for labor plus taxes. Then we had budget for 2 business trips for first year and second year, but we used this budget for business trip only for the first year. For the second year, the budget were assigned to buy new equipment. Organizational support and services, again, it's more about the vital costs, some health insurance, and so on. And materials, equipment, software, it's more about the workstations that we're buying. Yep. Reporting, we had done interim annual scientific and financial reports, and final report had to be done by December 31, but I think it's November 15th. So official finishing date is December 31, but report has to be done before 15th of November. And each year we are providing reports 2 times in June? Yeah, June and November. Use of funds restricted to project needs and relocation within categories per rules, which means that we can use the budget from the internships, like business trips, but we cannot move any budget to the business trip. From that, we can take it to there, we cannot move it. The same for salaries. Salaries are fixed. So the budget for salaries could be used only for salaries. And for outputs, we have the two publications in Q1, Q2 journals. And like with proper acknowledgements, we have one PhD holder and one master degree holder. Okay. Yeah, these are our publications. Okay. Conference and outreach. For the plan, we had this Informs annual meeting, which is the world's top conferences for operational research. And we were making two presentations on project results at the end of the first year in Phoenix in 2023. First presentation was delivered by me on the survey for machine learning methods to solve the vehicle routing problems, and second presentation was delivered by Bisimbayda Olitvayev for deep reinforcement learning framework to solve vehicle routing problem with drones. Yeah, ongoing dissemination, code release, and collaborations. We already started to develop this project further. The code is already released in GitHub and could be accessed by the request from authors. Yep. Well, the main risks that we had the compute bottlenecks for large instances at the beginning when we had not enough GPU resources. And so the main mitigation strategy was to scale GPU nodes from the action space and use the curriculum learning. Another risk is convergence instability that we had at the beginning stage of our experiments. Yeah, and mitigations are robust baselines, grading, clipping, learning rate schedules. And the main risk that we were facing at the beginning of our project for the almost the whole first year is simulator model mismatch, because usually when you start to develop, we develop the environment separately, and then we try to create the model and run the model with the simulator. And in most of the cases, they are not working together well at the beginning. That's why you have to spend a lot of time trying to run the model, log all the stages. Each step you need to log it and see at which stage what's happening, what's the problem, why it's happening, where in your environment you didn't do some assumptions correct. And you need to fix it. So most of the time for the first year first and half of the second year was spent for solving this problem, simulator model mismatch. That's why you do the progressive validation, ablation, real data calibration when available. And the next risk was delays in travel procurement and the funding again. And as a mitigation, early planning for the trips. We tried to plan it like half of the year before. For the equipment, we were, while applying to the grant, we were providing some companies, but while purchasing, we worked with alternative vendors because they were giving better prices. And virtual dissemination. So we had an option to participate online for some conferences, but yeah, there was no need for that. Yep. Yeah, the contacts is our PI. I need to fix that. Dr. Agin Bogorbaeva, and the institution is just as the university. I just copy pasted it from the application forum. That's why it's still in my review. Yeah, any questions? Yeah.
So I believe, as I remember, you submitted for in the under the category of computer science, like So I think of the next step, like making applied science.
Yeah, this year, hopefully, we are planning to apply as the applied project.
Okay, I'm just actually something or
No,
still computer science.
because and now the main benefit for us that do you know Abus is it? Abus? They are launching this drone delivery now. That's why we can talk to them. And since Freedom is our partner, we can have some nice collaborations.
Feel those interesting to field test and all these systems in
Real tests? Yeah, probably. But so the main idea of this project is the efficient like road management, road planning. And so we just assign the customers. This is the main goal. I'm not sure how we can test it, but yeah, maybe it would be good to have some real tests. But for now, we are
maybe not you, but you collaborators like
yeah. Now we are planning to at least if we are not, I'm not sure how we will develop in 3 years. Hope we will have the drone delivery implemented. But for now, we will first first stage will be to focus on only vehicle deliveries, and we will use the GIS technology, for example, to get the customer location and the distance real time to the customers, and then we will see how.
second question. Before they have some like industry collaborators, if I'm thinking of companies, industry companies, they might to apply it for commercialization for some
I think first of all we need to start from applied research to see how this will work, and if we'll have some real results in our hands, then we can apply to the institution to develop it further. Because for now it's just fundamental and there is no 100% guarantee that it will work in industry. That's yeah.
So this is fundamental project. Did you implement somehow to educational process your resume? Maybe creating some new courses or part of the course or master of the student maybe?
Yeah, there was the course called first of all applied AI, which was provided by our PI, Dr. Gambo. And I think there was a plan to implement the course reinforcement learning separate course. But our PI, yeah, she decided to continue only as a researcher.
You can show also some implementation here. Maybe it's creating of syllables or
yeah.
And show us how.
Yeah, sure. That can be done.
in the ground, what the difference between the fundamental research and the applied research?
Yeah, usually like for applied research, for fundamental research, we develop the model and we have tested it only in the lab, like without any real data. Like we use only synthetic data or some benchmark data sets. Yeah. And for applied research, first of all, it's mandatory to have some fault-finding, and we need to deliver some applied results. Within the like papers, we also have to have some applied results that could be further developed for commercialization. Any other questions? Yeah.
It's the final report.
Yeah. I'm not sure. I'm not sure, but probably around 40 pages. We just started to write it, so we'll see how it will end up at the end. So most of this information is already in my dissertation and it's already around 70, 80 pages, so you can partially use it for the report.
So you are describing the project. There's technology there.
Yeah.
Stuff, right?
Yeah. So it's in the report.
Yeah.
Let's ask the committee, because it's the first time also.
But I like the report with the data from the just and we look pretty similar to the report that we have done.
So I mean, should we go into the details in that final report, or should we just describe what we did? As for the non-experts, just say what happened.
Yeah, we'll see, because this is also the first time we're completing the project. So we'll apply and see if they will return it with some comments, and then we'll work on comments, because there is really low chance that even if everything will be done correctly, we'll say, okay, we'll accept.
No template, I think there should be templates.
There are templates without any specific information. So it's just template how the format have to be, but there is almost zero information what to be inside.
Yeah.
What to have to be inside.
We
And maybe why you decide what to put in the main site.
So should, okay, maybe this question is good. So should we complete the report till the 20th of November? And should we enter it to the system?
Yeah,
So the 1st of
the
November,
final report till first of November.
what if it returns? Like I said, with the comments to complete it, is it that we
I think
we
it's
send
probably the 1st of November. Hopefully the final step has to be to have things. Or sometimes
version should be in November.
if it could be earlier, it's better to make it earlier.
Maybe early October is it.
So this is not research related. Maybe we're looking at applying this, the scalability. Have you thought about that? How scalable is this?
Yeah, we already tried for the number of customers, and we started from 10 customers, and the maximum amount that we have tested was 100. And the more customers we have, better reinforcement learning framework work compared to the heuristics. Because more customers we have, more constraints we have, classical heuristics usually takes much more time to compute it, because they use classical algorithms and mathematical formulations. Here, since it's just deep learning models, they can produce results much faster. And with more customers we have, the more, I cannot say the more accurate results. They are producing the same results. Just the difference is that heuristics produce worse results. And in comparison, reinforcement learning beats the heuristics. So we tested up to 100 customers. Maybe we can see for more customers. We're limited in computational resources. To train each model for one combination took us around 1 week.
Wow.
Any other question? Thank you very much.
Yeah.
Thank
Great.
you.
Thank you.
Thank you.
Questions?